Um, During our discussion hour today, today is Monday, November 28th, that apparently there is some confusion about exactly homework 5, what kind of things you need to implement. So in the class, in another video, I show some techniques or skill that you can make um, object that moving among 3 server. But I would like to use this video to kind of conceptually to talk about what we really want to accomplish for homework assignment number 5. Okay, so let me just move it over here. Okay. Okay, so this is the slides conceptually about what homework assignment number 5 is about. So from homework assignment number 3, you develop a full record, which is showing some of the events that in the story about Little Red Riding Hood. So over there, we actually talk about this full record, but we also identify the location about each of the record took place. So for example, record number 1 and record number 2 happened in the home of Little Red. And then the third event is actually in the forest when the Little Red met the wolf. And the fourth record is happened in Grandma's home when Little Red actually arrived. So that's the full record and the corresponding location about what where the event took place. And just be careful that I actually wrote down also the person, the people, and the thing that's actually related to each of the record and how they move around when the record are played. So essentially what this diagram is trying to show you is that while the original Little Red Riding Hood was described in just natural language, such as English, that we're actually using this object-oriented model to recreate the story itself. So essentially, we only have a full record, but if you actually dig down and has lots of record, then essentially the diagram that we have is represent the whole story about Little Red Riding Hood, showing exactly the equivalent information about the original language. So essentially, just to let you know, I probably should have said that earlier. This is a way to convert a natural language into an object-oriented model that you can actually be able to process the information that in the original natural language description, and then be able to do a lot of application that's actually related to a story or a movie or anything or a paper or something. This is actually the kind of the watered down version about the powerful thing you can do with object-oriented paradigm. Okay, so in this simple example that you can see that we have for each of the record, it has a location and it has a person involved. So in record number 2, you have a Little Red, and then you have 3 things: the cap, the cake, and the wine. And at the forest, you also have a Little Red, but this time you have a wolf. That's actually be joining the record, and then you still have the cap, cake, and wine. And the interesting thing is that this is what we ask you to do about object mobility, is that while we're recreating the story using the object-oriented way, we need to represent where is the object, and therefore sometimes because in this case, each of the just go to the next. Each of the place is representing a server, a real computer that's in the internet, or is a program that's actually represent a location. So when we're moving from one location, because we're make a progress about the record, it's actually showing the mobility of the object. So for example, when we are want to show the story, that is important to have the capability when we transition from record number 2 to record number 3, we're actually be able to move the object from the first server, which is representing the home, which is an object called little red. And then this object need to be moved to another C++ object that's actually running the forward. So by applying this movement about the object and the thing, is actually representing the transition between one record to another record. So essentially, you think about what is a story like Little Red Riding Hood. It's essentially a sequence of record. And essentially, when I'm reading the whole story, is equivalent to basically just using object movement to represent each of the transition in sequence from the current record to the next record. So essentially, homework assignment number 5 is actually asking you to be able to recreate the movement of the object according to this 4 record, and according to we have a 3 program, each of them represent a different location. So in homework assignment number 5, we only have a 3 location, which is one represent home, one represent forest, one represent grandma's home. Okay. Okay, so we're going to explain for the remaining of this tutorial is just focus on the transition between record number 2 and record number 3. I will talk about the only other thing you need to do is actually to do the same thing because between record number 3 and record number 4, because between record number 1 and record number 2, you don't need to do anything because all the objects are in the same location, in the same program. Okay, so what we really want to do, I'm only focus on the person instead of the thing. You can do exactly for thing as well, just following my explanation about the person, which is actually the exactly the same code I demonstrate earlier today. So you can see that on this first server is the home, the second server is the forest. So essentially, for record number 2, the little red, which is a C++ person object, that's actually in the server home, which is HW6 home.cpp or HW6 home as an executable. So what I talk about a transition between record number 2 and record number 3 is really to move this C++ person object from HW5 home to the middle program, which is HW5 forest. So the thing is that for person, well, we need to move over here. By the way, the whole homework is actually you show all the movement that's actually representing what happened in the transition of the record. So in this case, if I only look at the between record number 2 and record number 3, that this is the things you need to move. So little red is actually moved from the home server to the forest server, or HW5 home to HW5 forest. And also you actually move three things. Cap need to be moved, cake need to be moved, and wine need to be moved. All right. And by the way, wolf, you don't need to be moved because wolf is not represented in previous record. It's not representing 2 and 1. So for this homework assignment, you don't need to move it. You might need to move in another way, but today we only simplify. That's why you don't need to worry about move. You in my way of expressing what you need to do is just seeing moving 4 objects from this server to this server. From the 4 objects are little red as a person, and then cap is a thing, cake is a thing, wine is a thing, to move from here over here. Okay. And then to actually express this in more detail, what we really need to do is that in the HW5 home.cpp, you need to have a C++ person represent little red. I'm only use little red, but you can generalize, apply to cap, cake, and wine. So you need to convert that using the function dump to JSON, which is you already done it in homework assignment number 3. And then you convert this to a little red JSON person object. And then you use the JSON RPC using the call move to actually move this object in the JSON to the HW5 forest. So now you actually should have the little red JSON object over there. Then you use the function you develop also for homework assignment number 3. It's called JSON to object. It will convert this to the C++ object. So in this sequence, you can see that if you implement this 2 functions successfully using the JSON RPC, you essentially move the object in C++ from this location to this location. And you just need to do this for not just the person, but also the 3 things. And you need to do this not just from the record number 2 to record number 3, which is from HW5 home to HW5 forest, but also you need to do transition from 3 to 4, which is from HW5 forest to HW5 grandma's place, grandma's home. Okay. So the thing is that, well, the other thing I think is important is how do you actually, if you've done this correctly, well, how do you actually successfully show that you actually done an object movement? So this is the way I expect that your code will show this 4 different steps. So for example, I'm giving this example for the transition to the record number 3, which is actually happened in HW6 forest. So the first thing is that your function move in HW6 forest.cpp, it should be called, should be RPC, remote procedure call, to call this move. And in this move, one of the arguments should be a JSON person representing little red. Okay, that is moving a person. And once you have this JSON person, inside that function, after all kinds of checks you need to do for JSON programming that you know is a valid JSON, the format is correct, then you use a JSON to object that will create you a C++ person object. So on completing step number 2, essentially your object mobility is done. You actually already finished that. But step number 3 and step number 4 is just try to show that your the object movement is actually correct. How do you actually show that? So once you have that C++ object, you actually call dump to JSON, which actually will generate back. So you got the JSON, you actually have a C++. Now you actually, from that C++, you generate a JSON again. And then what I'm saying is that if your movement is correctly, that the JSON person that's actually being used in the RPC call move should be equivalent, the same content as the dump to JSON that you just produced in step number 3. If your number 1 is equivalent to number 3, then essentially you have a correct object mobility from HW5 home to HW5 forest. By the way, this should be HW5 forest. Okay, so that's the way you can show. So essentially what I expect you to show is that you will do a two style string to print this JSON. And in step number 3, you actually do another two style string, cout, std colon cout. Then you actually will print two JSON output representing little red. And visually we can see they're the same thing. Then your program is correct. Okay, that's your TA is going to grade your homework assignment number 5. Okay, so the other thing I just want to just wrap up about what the homework assignment number 5 is trying to use. So I said here the main requirement to show for homework assignment number 5 is to show that the object, it could be person, could be thing, can be moved. What do I mean by move? I'm really talking about C++ to JSON, to RPC, then to JSON, and then to C++. So what I'm saying is that those things can be moved among the places, which is home, forest, and grandma's home. And they are basically represented by 3 different programs: HW5 home, HW5 forest, and HW5 grandma home. Each of this has a main program, but we call the HW5 home. It's just a program. So they're not just a single program like your homework assignment number 3. They're essentially 3 different programs, but they coordinate with each other to represent those transitions between record 2 to record 3 and between record 3 to record 4. I kind of talk about how you can do a programming about 3 programs in the video I showed earlier, or during the office hour discussion today. I use the term HW5 client, HW5 server, HW5 another, which is HW5 home is actually correspond to HW5 client. HW5 forest is correspond to HW5 server, while HW5 grandma home is corresponding to HW5 another. Okay, so that's essentially what we like you to do for homework assignment number 5. Just want to also reiterate the point is that as record number 1 and record number 2, they're from the same place. So you don't need to worry about the transition between record 1 and record number 2. You only need to worry about the object mobility issue involved